Okay, we are recording. So, and yes, I feel worse today, but I'll make it.
Hey man, just go home.
Yeah, just quit.
Take it to the house, get some vodka or something. You feel a lot better.
Rock and ride. Rock and ride. My son asked me, he said, "Daddy, are you going to pay for my way to go through college?" I said, "Hell to the no." I said, "You're going to work just like your sister's working."
I would like the top half. Parenchyma.
I guess I'm just a mean parent. I guess I'm just mean because I teach my children how to survive in the real world. I don't tell them that they can buy their way to go to college. Yeah, I'll go sell some steers and bribe somebody. But they want inequality out. They want that equality out there in Hollywood, don't they? They want that income equality, and they want everybody to be equal.
Yeah, I can't be in here.
Somebody turn the thermostat down or up. Was that Pendleton?
There's not one
There's
in
not a
here.
thermostat.
It's right there.
Oh man.
Yeah, there is. JC said there is. Y'all turned it off last semester. Where is it, JC? It's over there, on the left over there.
Should I mess with it?
There's not a dumpster.
That will light.
Turn it down?
Just put it on something where it won't turn on. All right. One way we can do this problem is change this to x plus 7 minus 1 over.
Look here.
You can just turn the AC on. True.
Just put it right in
Now
there.
we're using algebra before we're doing this problem, and that's because you can either do this problem as chain rule. We can do it with the chain rule, or we can do the algebra first, and that makes it equal to x to the 4th, x plus 7 minus 1 over x plus 7, and x to the 4th. What's x plus 7 minus 1?
Wait, we can't see what you're writing.
Beasley, can you see it? Who said it? Beasley, Oconee, can you see it?
Yes.
Okay, so Pendleton, I guess y'all just SOL. What do y'all see, Pendleton? Anything?
We just see the equation, that's it.
Like typed out with like the red numbers. We don't see anything that you've like written.
Okay, let me take y'all out. Hang up, Miss Shuttleworth. Hang up, and I'll bring y'all back in, okay? Did you hear me, Miss? Okay, she heard me. She didn't say anything. Did she say anything? I guess I'm just supposed to read her mind. We bring her back in. Okay, see if it comes up now.
Like I don't remember.
There it is.
I know I went. I just don't remember doing it. So,
It's a miracle. We should have called class off. That's what we should have done.
Yes.
That's a good idea.
Should have.
Yeah.
It's not too late.
Okay. Now we can go from here to first times the derivative of the second plus the second times the derivative of the first. X to the 4th times x plus 6 over x plus 7. I'm going to put an accent right there because we're going to take the derivative of that using the quotient rule, plus the second, x plus 6 over x plus 7, times the derivative of the first, which would be x to the 4th, and I'm going to put that with an accent. Or I'll just take a green marker and we'll highlight this in green because we've got to take the derivative and highlight this in green with the derivative. Okay, so go ahead and take the derivative of the first one using the quotient rule. And the derivative of the second one is 4x to the third. So x to the fourth. And we're going to put this in brackets. Denominator times numerator prime minus the numerator times denominator prime minus the numerator times the denominator prime over denominator squared. And plus, we'll put that in brackets, plus x plus 6 over x plus 7 times 4x to the third. And we're going to put these in green. Okay, now go ahead, because after this step, it's all what? Algebra. So I'll give you all a couple of minutes to finish it, because we've done all the calculus. And the only calculus left is, what is the derivative of x plus 6?
1.
What is the derivative of x plus 7?
1.
So y'all should be able to finish it. If you can't, then we'll just mark it up as being a disappointment. But don't worry. You can bribe somebody to get a better grade. That's what I need to do for retirement. I'll just start selling grades to people.
How much?
No, by the time Miss Porter would give me a check for $100, and by the time I got to the bank, I'd get a phone call. No, I couldn't do anything like that, because I'd get caught before I'd even. These people can do it for years and not get caught. I'd do it 6 minutes and I'd get caught. X plus 7. I'm going to put this in green. Times 1. Minus, brackets, x plus 6 times 1. Now, why did I put this x plus 6 times 1? Why do I have that in brackets? Why do I have this part in brackets right here? Because of what outside? Because that negative is going to change those signs, right? Yes, Hubert. Thank you. X, you can do 4x. Well, this pen is going crazy again. 4x to the third times, I'm just going to simplify it a little bit, x plus 7, x plus 6 over x plus 7. Now I'm just doing this step by step because I don't want to lose anybody. Even though y'all should be great at algebra by now. Okay, x to the 4th times 1 times, that's x plus 7, minus x minus what?
6.
Do you mind, Miss Shumway? Good God.
Sorry.
She's such a rebel. And we got to get a common denominator, but we'll do that here in just a second.
I was struggling.
And what's x minus x? They cancel, Hubert. That's right, class. And 7 minus 6 is what?
1.
And what's 1 times x to the 4th?
X to 4.
That's x to the 4th over x plus 7 quantity squared plus 4x cubed times x plus 6 over x plus 7. So we can need to get a common what? Common denominator of x plus 7 quantity squared. So I'm going to make it smaller again. So x to the 4th over x plus 7 quantity squared plus, well, x plus 7 quantity squared. How many times will x plus 7 go into x plus 7 quantity squared? X plus 7 times, so that's going to be 4x to the 3rd times x minus 6, x plus 6 times x plus 7. Now I've got x to the 4th plus battery going dead. No, it's just being funky. I don't know what's going on with this thing. Okay, x to the 4th x to the 4th plus 4x to the 3rd. Oops. I'm just all that drugs I'm taking. 4x to the 3rd times, well, what is that? X squared plus what? 13x plus 42 over x plus 7 quantity squared. And that's going to be x to the 4th plus 4x to the 5th plus, what's 4 times 13? 52? 52x to the 4th plus 100 and what? 168? Somebody help me out. 168x to the 3rd. Somebody check that last one. What's 4 times 42? That's a 1. So 4x to the 5th plus 53x to the 4th plus 168 x to the 3rd over x plus 7 quantity squared. And the only thing I could think other than that is to factor out x to the 3rd. I don't know if they've done that or not, but I'm going to do it over here. X to the 3rd, and that'll leave you with 4x squared plus 53x plus 168 over x plus 7 quantity squared. And I'm going to just highlight that one and this one, because I don't know what, we're going to go back to the question and see. Miss Novak, are you there? Miss Novak there?
No.
Okay, well, she was the one that asked this question, so I was going to ask her if she knew. So write those two answers down. Now, another thing you could have done is change this to x plus 7 to the negative 1 power. And I'm going to, as soon as y'all finish writing that down, y'all got it? Y'all got the answers written down? Anybody not have the answers written down? Okay. Let's go back to the beginning. Well, yeah, I'll have to bring the problem in again. And I'm going to show you another way. Of course, the way we did was just much more difficult. So I'm going to change this into f of x is equal to x to the 4th times 1 minus x plus 7 to the what? Negative 1. Okay, now you could do first times the derivative of the second, and I'm going to write that in green. 1 minus x plus 7 to the negative 1 prime plus the second times x to the 4th prime. Now, you don't know the chain rule when this homework problem is given, but now we do know the chain rule. Okay, you can't use the chain rule if you don't know it, but now we do know it. And this one will be x. And what's the derivative of 0? I mean, 1. I just told y'all. 0. So this negative is going to stay negative and bring this negative out front. What? I'm going to do this in magenta, showing you that I'm taking the derivative. So I'm going to just write 0 minus, what's negative 1 times negative 1? That's going to be a positive 1. And then that's x plus 7. What is negative 1 minus 1? Negative 2. And what's the derivative of what's inside? 1. Now I'll put brackets here, just keep it. Now remember, in the answer, we had x plus 7 to the second power in the denominator, right? What is this?
Basically.
X plus 7 to the second and bring it down and be in the denominator. So plus, let me go back to black, plus 1 minus x plus 7 to the negative 1 times 4x to the what? Third. All right, now simplify that. What do you mean simplify? Well, the 0 don't need to be in there. And the 1 times 1. So you're going to get x times what? X plus 7, which that x plus 7 can come down. So you'll get what? X over what? X plus 7 to the what? Second power. Plus, what happens here? Well, you need to distribute, technically, you need to distribute this 4x. So that's going to be 4x to the third times 1 is what? 4x to the third. And then this is going to be 4x times this, which this can come down, minus 4x to the third over what? X plus 7.
Hubert?
The first power.
Hubert,
Yes.
on your yellow and pink pieces of the problem to the far left, shouldn't that x be an x to the fourth?
Oh, thank you. Okay. And now it's just a common what? Denominator. And now you just did the algebra and you should come up with the same answer. And that's going to be x to the fourth over x plus 7 squared plus 4x to the third times x plus 7 squared over x plus 7 squared minus 4x to the third times x plus 7 over x plus 7 quantity what? Squared. And that's going to give us x to the fourth plus 4x to the third times x plus 7 quantity squared minus 4x to the third times x plus 7 all over x plus 7 quantity what? Squared. And you start to see this is going to be a square, right? What's square times the third? There's the x to the fifth. And you have x to the fourth. Here's an x to the fourth. So you're going to have your same answer if you keep going. Let's just go ahead and keep going and see what we get. X to the fourth plus, let's see, this is going to be x squared plus 14x plus 49, right? So that's going to be 4x cubed. I'm just going to x squared plus 14x plus 49 minus 4x to the fourth minus 28x to the third. I'll check my math there. Over x plus 7 quantity squared. And that's going to be x to the fourth plus 4x to the fifth plus 4 times 14 is what? 96? I have no idea. 96x to the fourth. 96x to the fourth. Check my math.
4 times 14 is 56.
56, thank you. 56x to the fourth. And then 4 times 49. Well, 4 times 50 is 200.
196.
196.
Yeah.
Plus 196x to the third minus 4x to the fourth minus 28x to the third. I'm not going to worry about the denominator right now. One x plus 56x is 57. 57 minus 4 is what? 53x to the fourth. 4x to the fifth. Plus, check that x to the fourth. 1 plus 56 is 57. 57 minus 4 is what? 53? Ain't that right? Plus 196 x to the third minus 28x to the third. Somebody take 196 minus 28. What do you get?
168.
Plus 68, what?
168.
Y'all check my answer on the last one.
That's right.
Of course it is. That's it. Now, as you can see, those are three ways that we did it. The first way that we tried yesterday, it was not good, okay? Because we didn't use the chain rule. We were trying to use this, and it was a pain. So if you want to try the first way again, knock yourself out, but you might want to give yourself a whole page of paper, because I think I've shown that sometimes you have to use some algebra at the beginning of the problem or revert to the chain rule. Now that you know the chain rule, and for those of you that don't know where the chain rule is, it's right here. There's the chain rule. Actually, it's right here. -1 comes out front, makes it a +1. You rewrite this, -1 gives you a -2, and then you take the derivative of what? What's inside? The derivative of x plus 7 is 1, and that's the chain rule. So that's a good question. I don't think I'd give it on a test, but it's a good question. Oh, let's check the answer on the. As soon as I figure out how to get out of here. There we go. Let's check and see what the answer was. Y'all just check it. I ain't gonna try to remember it. Oh yeah, that's what they got. Is that what I had? They factored out the x cubed, didn't they? Okay. Now they didn't write it the way that you want to write it. You never write it like that. I hate when sign. The way that you would write this is x to the third 4x squared plus 53x plus 168 over x plus 7 quantity squared. Nobody writes it like this. And you'd probably mark it wrong if you did write it the correct way. Okay, so I got that one done. Let's go back to questions because I think some more came in. And I want to cover chapter 3 questions because that's what you need to be worried about, because technically y'all ready for a test on chapter 2 and 3. So let's go with, okay, here's another one. This is 3.1. Okay, 3.1, 4x to the 5th. Basic what? Power rule. 4x to the 5th. Do the power rule. 4x to the 5th. Bring the 5 times the 4. X to the 5 minus what? 1. 5 times 4 is 20. X to the what power? Do 20x to the 4th. That's your basic power rule. That's the first rule we went over. And I do not take for granted that people don't know how to do these basic rules, because I'm going to tell you, I remember my first semester in calculus, the teacher went like 50 miles an hour through the first 3 rules, and I had no clue what was going on. So I know how that feels. Okay, a couple of good test questions here. What's the first thing you're going to do on this one? Rewrite it or do the derivative?
Rewrite it.
Rewrite it. Remember, fractions and radicals, automatic rewrite.
I think for this one, the problem that I was having was I couldn't figure out where they got the negative sign from. It just like appeared out of nowhere.
Well, it could be wrong because web sign sucks. So 5 over 2 times 1 over x to the what? 9. Everybody with me? Now what am I going to do with that 1 over x to the 9? I'm going to bring it up, and that'll be 5 halves times x to the what? -9. Now I've got a regular problem. What am I going to do with that negative 9? Multiply it times what? 5 halves times negative 9 over 1. X to the negative 9 minus what? 1. Remember, this negative 1 right here is the power rule. This negative 9 over 1 is the power rule. So 5 halves, 5 times 9 is what? 45 halves, x to the negative what? 10. Now what can I do? That's the same thing as 45 over 2 times x to the 10, negative 10 over 1. And what can I do with that x to the negative 10 over 1? Flip it. And my negative, forgot the negative, sorry. And it's going to be negative 45 over 2x to the 10th power. That should be your answer. Mr. Shuttleworth, how's that?
Yeah, that's better. That's better. I think wait, I can't remember now. Okay, I was doing this and I was trying to do it the whatever the other way is, and it wouldn't accept my answer. But I can just do it this way. It's fine.
Okay. Well, do you understand the calculus?
Yes, sir.
Okay. And you might have to, and make sure you put the negative out front of the fraction, because I can't remember if it's WebAssign or MyLabs Plus. If you don't put the negative in front, it'll mark it wrong. I don't know which one it is. If anybody's got any feedback, one of them does that. So if you was to type in the answer right here, you would hit negative, and then you would hit the fraction symbol or whatever you hit to type in a fraction. Put the negative out front of the fraction.
No Patriots WebAssign.
Okay, I think we did this one the other day. Did we do that one? I think we did.
Yeah.
Okay, let's go to another one. I'm trying to pull all the threes. Okay, I need to go over the quotient. I need to go over the sine and cosine. Let me just pull it up right quick, and all you need to do is go to trig, derivative, and go to images, and there they are. And just write down the first three, actually the first two, because in this class you're not going to use the tangent. But write down the first three. And that is the derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared. And that's the best way to remember it. Derivative of sine is cosine, derivative of cosine is sine, derivative of tangent secant squared. That's the only way I know to memorize it. Now you don't have to do anything mathematical to take the derivative of sine. You just have to write cosine. And that's why that's why I threw it in your homework, because there will be some times when you're talking about oscillation. Oscillation is when you go back and forth from -1 to +1, -1 to +1. That's called oscillation, and you do see that in graphs. So that's why you need to know the cosine and the sine. You don't need to know the secant by tangent, because the tangent doesn't oscillate like the sine and cosine wave does. Okay, so y'all got that written down? Sine, cosine, negative sine. Okay, so let's go back to the question. So let's do this one. And let me just go over here. And let me erase this and go to the whiteboard. Cosine of t over t to the fifth. Cosine of t over t to the fifth. Cosine of t over t to the fifth. Quotient rule. Denominator times numerator prime minus the numerator times the what? Denominator prime. Divided by the what? Denominator squared. All right, do it, because the only calculus left is just the green part, and y'all should be able to do that. The rest is just simplifying. You missed the thing I pulled up on Google. Derivative of sine is cosine. Derivative of cosine is the negative sine. Derivative of the tangent is secant squared. That's what I pulled up a while ago. So you need to write that down. So we'll take the derivative of the cosine. I'll do it in magenta because I don't have any posters. So that's going to be derivative of cosine is what? Negative sine t. And the derivative of t to the fifth is what?
5t to the fourth.
Okay. And t to the fifth minus parentheses cosine of t times t to the whatever over t to the what? 10th. Now just simplify as much as you can. The only thing you can do is pull that negative out, and that'd be negative t to the fifth. Negative t to the fifth times the sine of t minus 5t to the fourth times cosine of t over t to the 10th. Now you could pull out a negative t to the fourth, okay? And you could cancel out the t to the fourth and the t to the 10th, but the negative would not cancel, so you'd still have negative up the top. I would just factor out a t to the fourth, but it depends on what they want. I'll make this smaller, and I'll do several different answers. So we could factor out a negative t to the fourth. And that's going to give us what? T sine of t plus what? 5 cosine of t over t to the 10th. And that t to the fourth will cancel and make this t to the what? 6. So you could have negative t sine of t plus 5 cosine t, got to lay off the Marlboro Red, over t to the 6. Now you could have that as an answer, or you could have this as an answer, or you could have factored out just a t to the fourth, and then that would have been, you wouldn't have a negative out here, and it would just be negative t sine of t minus 5 cosine of t over t to the 6. You could have 3 different answers. Let's see what they did. And then y'all can make adjustments on your homework. Make a note, and that way when you do this one, you'll know which answer. So let's go back and look. Which one did they do? They just brought the negative out front. So which answer? Let's look. This one? That's the one they did, right? So you need to highlight this one and say, okay, that's what they're going to want. That's a good test question. Anything having to do with the chain rule, the product rule, or the quotient rule will make up pretty much 80% of Chapter 3 test, which is your Unit 3 test, I think. Because you're going to take the Unit 2 and Unit 3 test. I'm going to probably set it up today, and y'all can work over the break on it. Let's look at other questions she sent. Let's see, what is it? F prime of X. F prime and plug in. Now see, all they need to do is put F prime of 8. They don't have to put F prime. That's so stupid. All right, so here's X plus 3 over X minus 5. So do that. Let's go to the whiteboard. X plus 3 over X minus 5. X plus 3 over X minus 5. That's the quotient rule. X plus 3 over X minus 5. Is that it? So, denominator times numerator prime minus the numerator times the what?
Okay.
Times the denominator prime, right?
All right.
Over denominator what?
Where?
All right, y'all do it. I'm going to go back here and snort a couple of lines.
Sure.
Flonase, they say it's pretty good stuff. They're being very generous with y'all, because if I was to put it, I would put an x squared plus 3 and a 5x minus 5. They're being very, very generous with the low difficulty level here. Because what's the derivative of x plus 3?
1,
What's the derivative of x minus 5?
1.
You mess this up, you don't what?
Tell anybody.
You don't tell anybody. Right, Mr. Poor? You're awful quiet, Mr. Poor. You don't feel good. You done got sinuses too. X minus 5, just go do a couple of lines. Flonase. X minus 5 times 1. Oops, we got to turn that magenta color. I need to use, if I use posters, I wouldn't have to use all these different colors.
That's right.
But I'm doing it for y'all. Now it's all algebra. So x minus 5 minus x minus what? 3 over x minus 5 quantity what? Squared. And that's going to give us negative 5 minus 3 is what? Negative 8 over x minus 5 quantity what?
Squared.
Squared. And evaluated at 8, because they gave us to plug in 8. So what are you going to do with that 8? Plug it in. You get negative 8. That's A. Now we're going to do B. Okay, negative 8 over 8 minus 5 squared, negative 8 over 8 minus 5 is what? 3 squared is, somebody give me that decimal, negative what? What's 8 divided by 9?
.88888.
Point what?
0.8. It's just repeating 8.
Point 8? 0.89?
Yep.
So, again, most of the time when you see there's your answers. It's a good test question, but I just don't like it because that f prime of c, you never see that. It's usually f prime of what? 8. And you plug that's just... Good test question. Sine of x over x. Quotient rule. And then plug in pi over 4. Well, all you got to do is plug in pi over 4 is the same as 180 over pi, which is 180 over, what's 180 over 4 come out to be? 45? So 45 degrees. So that change that pi over 4 to 45 degrees. I'm going to go over here, sine of x over x. Sine of x over x. F of x is equal to sine of x over x, and at B, they want f of 45 degrees. All right, so denominator times the numerator prime, oops, sine of x prime minus brackets the numerator times x prime over denominator squared. And what's the derivative of the sine? Cosine. So x times cosine of x minus bracket sine of x, because what's the derivative of x? That means I want y'all to interact.
1.
Thank you, 1. So your final answer is x cosine of x minus sine of x over x squared. And now they want you to plug in, write that down because that's your answer. And then we're going to plug in 45 degrees. So 45 times the cosine of 45 minus sine of 45 over 45 squared. And then you just reduce that down. Cosine of 45 is what? Cosine of 45 is square root of 2 over 2 or something like that. I don't know. I can't remember it. Well, especially when I'm not in trig mode. Sine of 45, do that in your calculator. And I don't know how they want you. They probably use pi over 4. I don't know how far they take it down, but let's see how far they take it down. See, they really don't. Yeah, it is square root 2 over 2. So they really don't. If you did, it would work better with pi over 4, because if you put pi over 4 in there, you'd see it would work out a whole lot better. So just make a note on this question, don't use the degrees. So pi over 4 times cosine of pi over 4 minus the sine of pi over 4 over pi over 4 quantity squared. Okay? I'm not going to really worry about that much. All I care about is you. All I care about on this test is if you can take the derivative using the power rule, the quotient rule, the product rule, and the chain rule. That's all I'm going to test you on chapter 3. Okay? That's it on that one. Ms. Shuttleworth, you good on those?
Yes, sir.
Last one on chapter 3. Yes, there's a test question right there. And a lot of people say, well, why do you give such an easy problem? That's one of the most difficult problems for students to do on a test with the power rule. Why? Because they don't know how to rewrite a radical. You have to rewrite the radical x to the what power?
Second.
X to the 1/3. So rewrite x to the 1/3 power. Remember, it's exponent over what? Index. So that's x to the first power. If that was x squared, it would be x to the 2/3. If it was the 5th root of x to the 3rd, it would be x to the 3/5. It's always exponent over index. And now you just use the power rule. 1/3 times 1 is what? 1/3 x minus 1 minus 4/3. 1/3 minus 3/3. And that's going to be 1/3 x to the what? What's 1/3 minus 3/3? And to break that positive, you bring that down, and your final answer is 1 over 3x to the 2/3. Now, if you notice how Miss Ingram typed this in, what did she use? Right here? Parentheses. Is that smart? Yes. So, if you get one on test, you might want to put that in parentheses. Next problem. Okay, this one's a bear because you got to use the product rule right here, and then take the derivative of that one. So you got to use the product rule here. So let's just write pi over 8 sine of theta minus cosine of theta. So here, let me do this. Snip. There we go. Actually, you don't have to worry about the product rule because this is basically a number. But if that was a 2 sine of theta, then the derivative of 2 sine of theta is 2 what? Cosine of theta. So it looks like to me this. You could use the product rule, but you don't have to. I'm going to use the product rule just to do it. Okay? First, times the derivative of the second plus the second times the derivative of the first minus, and we just go ahead and take the derivative of, because minus, you don't need a, just minus, what's the derivative? Well, we'll just write cosine theta, and then we'll take the derivative of that. Everybody with me? Now, you don't have to use the power rule for the first one. I'm just showing you what happens when you have a pi. This is the same as a number, because 3 divided by 8 is 3/8. Y'all know today's Pi Day? Happy Pi Day. Anyway, pi over 8 is a constant, so 0, that cancels that out. So take your handy dandy. That cancels out because that's a 0. So you're left with, what's the derivative of the sine? Cosine. So pi over 8, oops, I'm sorry. Cosine of theta, I'll change that because I don't want to mess up, I don't want to mess y'all up. All the things I do. Pi over 8, cosine. And then, what's the derivative of the cosine? Be careful. Negative sign. But what's in front of that cosine? The negative. So what happens to these two negatives? Becomes a positive, and that gives us positive sine theta. I'm getting confused with my colors. There. So that's your answer. So write that down. Let's make sure that's the answer they got. Yep. Let's go down here. What's the derivative of 9?
0, nothing.
0. So 0 plus 9 cosine theta. And what's 0 plus 9 cosine theta? 9 cosine theta. So that's all that's there. That's a good test question. Let's do that one. 7 over 5x to the 8th. 7 over 5x to the 8th. What did I do? I rewrote it. Now what do I do if I want to bring that x to the 8th up top? I flip it, right? That'll give me 7 over 5 times x to the negative 8 over what? 1. So that negative 8 comes out here. That's going to be negative 8 over 1 times 7 over 5 x to the negative 8 minus what? 1. And what's 8 times 7? Is it 48 or 56? 48, 56, isn't it?
Yeah.
Yeah, Hubert. No, Hubert. Thank you, class. And I want to make that 9 positive, so I flip it. And my final answer is negative 56 over 5x to the 9th. And remember, put your 50, that negative, make sure you put it out front of the fraction. When you type in your answer, make sure, I'm going to put a highlight there, make sure you put that negative out front. That's another one. We done went over one like that one. bring that x to the negative 2 up, be negative 16 x to the first power. We've already done that one. And plug in 1. This one is a good question because now that you know the chain rule, you can actually take the derivative of this one using the chain rule. Let's just do this one as a chain rule problem. Okay? 3 times 7 minus x, quantity squared. I want you to take the derivative with the chain rule. I'm just ignoring the question. 3 times x, 7 minus x, quantity squared. You bring the 2 out front. So that's 2 times 3. 7 minus x to the 2 minus 1. And then what's the derivative of the inside? Not 1, negative 1. Huh?
Wait, why is it negative 1?
Put your 1 right here.
Oh.
1 times 1 is negative 1. X to the 1 minus 1 is 0. X to the 0 falls off, so it's negative 1. And what's negative 1 times 6? Negative 6, Hubert. Thank you, class. 7 minus x. What's 2 minus 1?
1.
And you could distribute that and get negative 42 plus what? 6x. Either one of these is the correct answer. Oh, I don't know about this question because I think all they want you to do here is plug in 7 for x and you get 0. That's all they want you to do there. But I ignored the directions. This is use the chain rule. Okay, the directions will say use the chain rule, and I just did that. And if you want to do this problem, just plug in 7 for what? X, because that's an x, and you get 7 minus 7, 0. 0 times anything is what? 0. So that's just plug and chug. I just thought this would be a good problem to go over to the chain rule. Okay? I think that's all the questions I've gotten out of chapter 3. And I think oops, sorry. Let's see. Yeah, that's all the questions I got for chapter 3, and I think I already covered that chapter 2 question, but I'll look at it. 2.5 different. Yeah, you could actually use the derivative here. You could take 2 times 1.2 is 2.4t minus 5.5. You could just do the derivative. You don't have to actually do the... Let me tell you, on these decimals, I'm not going to ask you to do the quotient. The difference quotient, just do the derivative. 2 times 1.2 is what? 2.4, Hubert. And then 5.5t to the first power comes out to be 5.5. Just to do the derivative. And then, of course, plug in. We're asking you to plug in whatever number from 2005. That'd be 5. Plug 5 in, and you should get that answer. All right, remember this one. This one is the one that you need to do on your calculator. Okay? Quadratic, we did that one the other day. Trend line, if you use the, so that we've already covered that one. All right, so let's take a look at our homework. I think, let's see. Yeah, that's all the, let's see. Okay, exponential derivative, which that's not a big deal. Preview, see what I do on that one. Yeah, better wait, because I gotta cover the natural log. Derivative of 1 over x is natural log. Okay, so what y'all need to be working on for homework is y'all need to be doing chapter 2, and you need to do the homework up to 3.3. Okay, when we get back from break, we will finish 3.3, and we'll have a test on chapter 2 and chapter 3 right after we finish these 2 sessions, okay? So enjoy the break, and I want to take the roll right quick, and I'll shut the roll off.